Good day everyone. Our lesson for today is all about dot product and matrix multiplication, particularly dot product or inner product, matrix multiplication, matrix vector multiplication, linear system. In this section, we introduce the operation of matrix multiplication. Unlike matrix addition, matrix multiplication has some properties that distinguish it from multiplication of real numbers. So at the end of this lesson, you will be able to perform the dot product and matrix multiplication of compatible matrices, express the given system of linear equation as a linear combination. Definition 3.1: the dot product or inner product of the n vector in R raised to n. For the real numbers, so we have A equals the vectors of a sub 1, a sub 2, ellipses up to a sub n, and b equals the vectors of b sub 1, b sub 2, ellipses up to b sub n is defined as a times 1, or I mean a times b, or a dot b is equal to a sub 1, b sub 1, plus a sub 2 times b sub 2 plus ellipses plus a sub n times b sub n is equal to the summation of a sub I, b sub I, where I is equal to 1 up to n. Example 3.1. The dot product of u is equal to the vectors 1, negative 2, 3, and 4, and v is equal to the vectors 2, 3, negative 2, and 1 is u times v. Ito yung representation kanina. So u times v mean to say u is 1 times 2 plus negative 3 times 3 plus 3 times negative 2 and plus 4 times 1. So ganito yung representation niya when you do a dot product for a for vector both matrices, no? So, ayan. So, we have 1 times 2, which is equal to, so let's solve to show the solution sa inyo. So, we have here, this is 2 plus negative 6 plus negative 6 plus this is 4. Am I right? Am I doing it right? So cancel this and this. So we have negative 6 as our final answer. Example 3.2, let A is equal to the vectors x to 2 and 3 and B is equal to 4, 1, and 2 if A times B is equal to negative 4. So let's try to find out if it is equal to negative 4. Then find x. So first we need to find x. So we have x, a times b, multiplication of the two vectors. So a times b equals 4 times x, that's correct. Then 2 times 1 is 2 and 3 times 2 is 6. So we have here 4 equals negative 4, I'm sorry. So a times b is equal to negative 4. So we have 8. So we have 4 times 4x plus 8 equals negative 4. And as we all know, this is equal to, okay, negative 12. No, this one. If you transpose this is negative 8 plus negative 4 is negative 12. Divide both sides by 4 to cancel 4 in the x. So we have x equals negative 3 as our final answer. I hope you get it because that's too basic, no, for the, what they call this, for the process of uh, property addition property of equality, okay, and the division process, no, for finding the value of x. So x is equal to negative 3 for this one, okay. So that's our answer. Now if you want to check it, you can change it into negative 3 and then multiply all of this and then add your product and you will get negative 4 as your final answer. So, ganun siya. Now, Matrix multiplication. Actually, this one is already a matrix multiplication, no? A dot product. Now, let's continue the matrix multiplication. If A is equal to the square bracket of A sub ij is on M by P matrix, and B is equal to the square bracket of P sub ij is a P by N matrix, then the dot product of A and B denoted by AB, yun yung multiplication nila. This is denoted by this, is the M by N matrix. C is equal to the square bracket of C sub ij defined by C sub ij is equal to A sub I 1 B sub 1j plus A sub I2 B sub 2j plus ellipses plus A sub ip B sub I 1m is equal to the summation of A sub ik times B sub kj, where I is equal to 1 up to P, and I is greater than or equal to 1 but less than or equal to M, and I is greater than or equal to 1 but less than or equal to N. Equation 1, this one, states that the jth element in the product matrix is the dot product of the transpose of the ith row sub I of A, that is the square bracket of row sub I of A raised to T, and the jth column called sub J of B of B. Okay, maybe you might get confused about this very crucial definition. So to understand it better, I think having an example is really a matter. So let's have this example. This is a 2 by 3 matrix, and this one is a 3 by 2 matrix. Okay, it has a 3 columns, 2 by 3. This is a 2 by 3, sorry. So this has a 2 rows and 3 columns. This one has 3 rows and 2 columns. So how to multiply this? So let's have A times B is equal to, the first thing to do is we will focus, no, doon sa ang tawag dito, dito sa kanilang dito sa anong tawag dito, row, no? So row versus column. Ayan. Row versus column. So we have 1 times negative 2, 2 times 4, negative 1 times 2. Okay? And then you need to put a comma here para may distinction muna. Anyway, we can erase the comma after. Ang ginagawa lang natin dito is para may distinction lang. Okay? But we can, tawag dito, delete it later. So, 1, negative 2, 4, 2, and then 4, negative 1, and 2. That is parang row versus column. Parang ganun siya eh. Yun yung multiplication ng matrix. Then, the next one is, still dito pa rin tayo, pero dun sa next na. 1 times 5, 2 times negative 3, negative 1 times 1. Ito yan, no? Ito yung sinasabi ko. Yung kanina, yung first row tsaka first column, ito yan. First row, second column, ito yan. So, nasa first row pa rin ito kasi first row. Next one, dito na. So, second row, first column. So, 3 times negative 2, 1 times 4, 4 times 2. Ito yan. And then, 3 times 5, this one. 1 times negative 3, this one. And 4 times 1 is this one. Okay? Then, after that, i-add lang i-multiply natin, and then i-add natin yung product ng mga ito. So, we have 1 times negative 2 is negative 2 plus 2 times 4 is 8. So, that is 6. Then, negative 1 times 2 is negative 2. So, that's equal to 4. So, we have 4. 1 times 5 is 5 plus 2 times negative 3 is 6. So, we have negative 1. Then, negative 1 times 1 is negative 1. So, negative 2 is our answer. 3 times negative 2 is negative 6. 1 times 4 is 4. Minus 6 is negative 2. 4 times 2 is 6. So we have 8 8, I'm sorry. So we have 6 as our answer. Then 3 times 5 is 15, plus negative 3 is 12, plus 4 is 16. So we have 16 here. So this is our answer. This is the product of AB. A product of AB matrices is 4, negative 2, 6, and 16. Okay, I hope you get what I mean. Yeah, no? So, ganun lang siya. So, or pwede mo siyang, kaso medyo maproseso yung naiisip kong isa, no? Yung ang gagawin mo muna is 1, kukunin mo yung 1, and then, paano kasi yan? 1, ay hindi pala. Iba pala yung iniisip ko. I'm sorry. So, we have 1 times negative 2. Ayan siya. Then, ito. Then, after that, balikan natin yung 1, pero next na. Then, next. And then, next. And then, for this one, babalik ka doon sa, again, basta row versus column. Then, row versus column. Hanggat hindi natatapos yung mga column dito, ito pa rin yung gagamitin mo. And for instance, tatlo yan, may mga numbers pa dito sa part na to. So, hindi pa tayo matatapos dito hanggat may mga numbers pa dito. Okay, so magko-continue siya. Dito naman, and then you put a comma, no, to put emphasis na lang. Anyway, alisin mo na lang yun when you do the final answer. Para lang hindi ka malito kasi baka ma-add mo yung ito dito sa kabila. No? Unfortunately, may mga ganong instances. Okay, now let's have this one. A is equal to square bracket of 5, 7, negative 3, 0, and B is equal to square bracket of 1, 2, 9, and negative 1. Calculate the product of AB and BA, and let's see if they are the same. So since both matrices A and B have the dimension 2 by 2, both products AB and BA are defined, and each product is also a 2 by 2 matrix. For the AB, we have 5, negative 3, 7, 0, 1, 9, 2, and negative 1. So we have 5 times 1, okay, row versus column. So 5 times 1, 7 times 9. This one. Ito yan. Okay, then next one, since meron pang another column, so we we have 5 times 2 and then 7 times negative 1. So ito yan. Then negative 3 times 1, balik tayo, and then negative 0 times 9, negative 3 times 2, and then 0 times negative 1. Then get the product and the sum. So we have 5 times 1 plus 7 times 9 is 68. 5 times 2 plus 7 times negative 1 is 3. Sundin mo yung tinatawag nilang MDAS. Okay? Hindi pwedeng 5 times 2 plus 7. Hindi pwede yan. Yung multiply ka muna bago ka mag-add. The negative 3 times 1 is negative 3 plus 0 times 9 is negative 3. So negative 3 times 2 plus 0 times negative 1 is negative 6. Okay, so this is now the product of A and B. Now let's see the B and A if they are the same. Unfortunately, they are not the same. Okay, they are different. But let's see how it goes. So we have 1 times 5, 2 times negative 3, 1 times 7, 2 times 0. Ito yan. Okay. Next, 7 times 5, and then negative 1 times negative 3, then 9 times 7, and then negative 3 times 0, and then get the product and sum. We have negative 1, 7, 48, and 63. This shows that in general, AB is not equal to BA. In fact, in this example, AB and BA don't even have any entry in common. Okay? So, yan. They are not the same. Okay, I hope you know now the process of solving multiplication of matrix. Now let's have another example to have you more and have an idea. So we have this, let A 140 negative 221 31 negative 2 and B is equal to 1 3 negative 2 4 negative 1 2. Compute the 3 by 2 entry of AB. So we will have 3 and 2, I'm sorry. So we have A and times B. So if AB is equal to C, then the quantity 3 to entry of AB is 3 and 2. AB is in column in C sub 3 2. Okay, 3 2. Then which is row 3 of A raised to T row 3, this is row 3 of A. Where's the row 3 of A? Tapos kukunin mo yung ang tawag dito, yung kanyang uh, transposition, okay? And then for the column 2 of B, where's the column 2? This is the column 2 of B. Kasi sabi, compute the 3, 2, and 3. 3, 2, 3 for the row and 2 for the column. Row and then column. Column 2B, we now have this one is equal to 0, 1, and negative 2. Ito yan kasi we do the transposition. Okay, and then we have B, which is 4, negative 1, and 2. We multiply them and then we add. Then, so 0 times 4 is 0. 1 times negative 1 is negative 1. Negative 2 times 2 is negative 4. Negative 4 plus negative 1 is negative 5. I hope you still remember this. I already told you about this if we go back. At the end, diba? Okay. The jth and the ith of row I1, A, and at the end. Column J. Ito yan, di ba? Ito yung sinasabi ko kanina. Okay. So, let's go back. So, let A is equal to the square bracket of 1x, 3, 2, negative 1, 1, and B is equal to 2, 4, and Y. So, we have this vertex, I'm sorry, this matrices A and B. So, if AB is equal to 12 and 6, find X and Y. If AB is equal to 12 and 6, ito yung parang answer nila. Find X and Y. So, we have AB is equal to 1x, 3, 2, negative 1, 1, and then 2, 4, and Y. Which is, kapag inano natin, minultiply, sinolve natin, we have 1 times 2, x times 4, and 3 times y. So, end na yung column, no? Kasi, di ba, row times column yan. And then, after that, 2 times 2, kung ano yung position dun sa baba. Okay, since yung next natin is row 2, so dito tayo sa row 2. Hindi pwedeng dito, diretso dito. So, 2 times 2 is 4, negative 1 times 4 is negative 4, and 1 times y is y. Is equal to 12 and 6, AB, for the AB. Okay, now, suppose this is a 2, ayan, no? Ano siya, dalawang linear ba ang tawag doon? Okay. Linear system sila. So, we have 2 plus 4x plus 3y equals 12. And then, 4 minus 4 is 0. So, that's 0. Y is equal to 6. So, for this one, to solve for, we have already a y. So, y is equal to 6. So, to solve for x, we need to change this into 6. Right? Yan siya. So, 3 times 6 is 18 plus 2 is 18 plus 2 is 20. Tapos, addition property of equality, that will become negative 20. And then, 20 or 12 minus 20 is negative 8. We have the x here, so divide both side by 4. Tama? Yung makukuha nating difference dito, divide by 4. And you will get negative 2. Therefore, x is equal to negative 2 and y is equal to 6. Ayan. So, meron na tayong nakuhang value for x and value for y. Okay? So, kompleto na siya. So, therefore, this x is equal to negative 2 and this y is equal to 6. And if you will do a matrix multiplication, you will get an answer of 12 and 6. Okay, a 2 by 1 matrix. Multiplication of matrices requires much more care than their addition, since the algebraic properties of matrix multiplication differ from those satisfied by the real numbers. Part of the problem is due to the fact that AB is defined only when the number of columns of A is the same as the number of rows of B. Thus, if A is an M by P matrix and B is a P by N matrix, then AB is a M by N matrix. What about BA? For different situation may occur. BA may not be defined. This will take place if n is not equal to m. If BA is defined, which means that m is equal to n, then BA is P by P, while AB is M by M. Thus, if M is not equal to P, I mean, AB and BA are of different sizes. If AB and BA are both of the same size, they may be equal. If AB and BA are both of the same size, they may be unequal. Okay, if I'm not mistaken, I already showed you about this, the AB and BA, if they are equal or not. And as you can see in the previous example, they are not equal actually. No? So if A is a 2 by 3 matrix and B is a 3 by 4 matrix, then AB is a 2 by 4 matrix while BA is undefined. Is undefined siya, no? Parang sinasabi dito, yung magiging resulta, if it is a 2 by 3, means to say it's a 2 rows and 3 columns, and B is a 3 rows and 4 columns, probably the AB, the combination of AB is 2 by 4 matrix, while BA is undefined. BA is still undefined. We don't know yet. Okay? So let A be a 2 by 3 and B is a 3 by 2. Then AB, yung kanilang extreme, 2 by 2. So we have 2 by 2 while BA is 3 by 3 because they are equal. If you know what I mean. Na, so, yan. Yan yung kanilang magiging result. So let A is equal to 1, 2, negative 1, and 3, and B is equal to 2, 1, and 0, and 1. So AB is 2, 3, and negative 2, 2. If you will multiply A and B, yung result nila 2, 3, and negative 2, 2. You can check it by doing the same process na ginawa natin kanina. While BA is 1, 7, negative 1, and 3. Obviously, they are not the same. Okay, the matrices inside this these linear are not the same. Therefore, AB is not equal to BA. But since they are equal in number of column and row, so therefore 2 by 2 pa rin yung resulting or result nung AB tsaka BA. Pareho silang 2 by 2. Unfortunately, they are not the same in terms of matrices. Okay? Now, let A is equal to the square bracket of 1, 2, 3, 4, negative 1, and 5, and B is equal to the square bracket of negative 2, 3, 4, 3, 2, and 1. Okay? Then the second column of AB is the second column. We're talking about the second column of AB. A column 2B. Okay, so A, this one, and then the second column is 3, 2. Yun ang pinag-uusapan natin. The second column of AB, so that is this one and this one, ay magiging ano. So if we will do the same process of, what they call this, multiplication of matrix. So we have 1 times 3, 2 times 2. Okay, you will get 7. Then 3 times 3 and 4 times 2, you will get 17. Negative 1 times 2 plus negative 5 times 2 is equal to 7. Okay, so this is now the result, 7, 17, and 7. Remarks, if U and V are n vectors of n by 1 matrices, then it is easy to show by matrix multiplication that U times V is equal to U raised to T V. This is a transposition. Okay, so again, in this portion, the condition is the second column of AB. Okay, the second column. So we are solving to the second column. Okay, so we have this A and then the second column of B. Column sub 2 of B. The matrix vector product written in terms of column, let A is equal to this representation of matrices from A sub 11 up to A sub M1 and up to A sub 1 and up to A sub Mn be an m by n matrix and let C is equal to the vectors of C sub 1, C sub 2, ellipses up to C sub n, be an n vector that is an n by 1 matrix since A is m by n and C is n by 1. The matrix product AC is the m by 1 matrix. Okay, so this is the representation of AC equals the square bracket of A sub 11 ellipses up to A sub mn times C sub 1, C sub 2, and so on up to C sub n. AC at the end, A and C at the end, is equal to the row 1 of A raised to T times C, row 2 of A raised to T times C, row sub m of A raised to T times C. So, ito yung magiging result niya. Kumbaga, pinapakita lang dito yung properties. Okay, properties. Pero, ginagawa na natin siya kanina pa. Okay, yung A sub 11 times C sub 1, edi A sub 11 times C sub 1. Okay? So, kanina pa ito. Okay? Na, pinapakita ko lang yung parang theory niya. Okay? So, in this last expression can be written as this one. C sub 1, A sub 11, yan. C plus C sub 2, yan. Pwede siyang gawin na ganyan. Okay? Parang it's just like similar to distributive property, parang ganon. Is equal to C sub 1 column 1 of A plus C sub 2 column 2 of A plus ellipses plus C sub n column n of A. Okay. Now, thus the product AC of an m by n matrix A and n by 1 matrix C can be written as a linear combination of the columns of A where the coefficients are the entries in the matrix C. Example, let A is equal to 2, negative 1, negative 3, 4, 2, negative 1, and C is 2, negative 3, and 4. Then the product AC, written in the linear combination of the column of A, is AC equals this one, these two linears, matrices. So we have 2, and then this, versus that. Okay, baliktad siya na 2, and then this one, 2 and 4, minus 3, yan, negative 1 and 2, plus 4, negative 3 and negative 2, so you will get negative 5 and negative 6. If A is n, I hope you get it, how it goes like this. Okay, so if A is an m by p matrix and B is a p by n matrix, we can then conclude that the jth column of the product AB can be written as a linear combination of the columns of the matrix A, where the coefficients are the entries in the jth column and of matrix B. So that is column of J, or column sub J of AB is equal to A column of sub J of B, and is equal to B sub I J column sub 1 of A plus B sub 2J column sub 2 of A plus ellipsis plus B sub PJ column of sub P of A. Okay, parang it's just a what do you call this? A representation of the theory of this definition. Okay, so yan. So example, if A and B are the matrices defined in example 9, then AB, ito yan, 1, 2, 3, 4, negative 5, negative 1, 5, negative 2, 3, 4, 3, 2, 1, then the answer would be this one. Okay? So we have negative 2, parang, yeah, negative 2, and then 1, 3, 3, I'm sorry, am I doing it? Sorry, negative 2, this one, no, negative 2 and teka lang, nalito ako. Negative 2. Hindi naman pwedeng gito. Okay. 1 times negative 2, 2 times 3, that's 4. 1 times 3, 2 times 2 is 7. 1 times 4, 2 times 1 is 6. Okay? And then, nakakasunod na. 3 times negative 2 plus 3 times 3 is 6. 3 times 2 plus 4 times 2 is 17. 3 times 4 plus 4 times 1 is 16. Negative 1 times negative 2 plus 5 times 3 is 17. Negative 1 times 3 plus 5 times 2 is 7. Negative 1 times 4 plus 5 times 1 is 1. The column of AB as linear combination of the columns of A are given by column sub 1 of AB is equal to 4, 6, 17. Column 1. Column 1 is equal to A column of 1 of B is equal to negative 2. So, pwede siyang ganon. Negative 2, the first column, and positive 3, the second column. A column of sub 1, B. Pareho lang daw sila ng magiging answer. I guess so. Yun ang sinasabi, no? So, probably, magiging ganun din yung answer nila. And column 2 of AB, which is 7, 17, and 7, kapag ganito daw, ito daw, yung product, yung sum nito, after ng product nila. No, kasi this, ano yan eh, ang tawag, scalar multiplication, no? And then, i-add mo sila. Ito daw din yung makukuha mo. And then, this one. Okay, if you distribute this parang pabaliktad ba ang tawag doon? 4 times 4 times 1, 4 times 3, 4 times negative 1. And then for the next is 1 times 2, 1 times 4, 1 times 5. Ito yan. Then yung nakuha mo addition, product nila, i-add mo. So 4 times 1 is 4, and then 1 times 1, 2 is 2. 4 plus 2 is 6. So answer is 6. Tama. 4 times 3 is 12, and then 1 times 4 is 5 plus 12 is 16. And 1 times 4 is 4. 4 plus, times 12 is 16. Then 4 times negative 1 is negative 4. 1 times 5 is 5. So the answer is positive 1. Ito yan. So, ganun din daw yung makukuha mo. Parang it is just another representation on how you get the answer for a matrix. But you can do the same thing that I've made in the past, that by multiplying the row to the column. And then multiplying it, and then adding the product of the what do you call this, of each, no? So parang ganun din siya. The same thing, ganun din yung makukuha mong answer. Okay? But here, if there's a condition na ganito siya, halimbawa sinabi niya ito, so you need to do the process. So you will go to the column of 1B. So this is column of B times the row of A. Times the column of A. Tama ba? Column of A. So we have negative 2, and then ito yan. Then 3, ito yan. Okay, so dito naman, column number 2 of B. And then multiply to the column of A. So we have 3, ito yan. Itong line na yan. And then 2, ito namang line na yan. Then column of sub 3 of B. So this is 4, 1. Multiplied to A. So we have 4 to this column and 1 to this column. And then you will get this one. Okay? So still, pag pinag-combine mo yan, you will get the same thing as what I did a while ago. Linear system, consider the linear system of m equations in n unknown. So it has a representation of a sub 11 x sub times x sub 1 plus a sub 12 times x sub 2 plus ellipses of a sub 1 and x sub n equals to b sub 1 up to the ellipsis of a sub mn, x sub n equals b sub m. Now define the following matrices as this. Ito yung original nating matrix. Then x is equal to x sub 1, x sub 2 up to the ellipses up to x sub n, and b is equal to b sub 1, b sub 2, ellipses up to b sub m. Ito yan. This one. Ito yung answer na to. Okay. Yung x sub 1, x sub 2 up to x sub n. Ito yan. So, ax is equal to this one. A sub 1 up to the ellipses up to a sub mn, x sub 1, x sub 2, ellipses up to x sub n is equal to this equation. Parang ganyan siya. It's just like a combination. Parang distributive. So the entries in the product of ax at the end of 5 are merely the left sides of the equations of 4. Hence, the linear system 4 can be written in a matrix form as ax equals b. The matrix A is called the coefficient matrix of the linear system 4. Number 4, that's number 4. Where's that number 4? Di kaya nasulat. I think this one. This is the number 4. Okay? That is A sub 11 up to A sub mn, B sub 1, B sub 2 up to B sub n. A representation for ax equals b, obtained by adjoining column b to a, is called augmented matrix of the linear system of the number 4. The augmented matrix of 4 is written as the square bracket of a slash b. Para siyang, it's similar to probability, no? Parang, I'm not sure if that's an intersection or what. No, that's not an intersection. I just forgot what's that symbol. Okay, anyway, conversely, any matrix with more than one column can be thought as the augmented matrix of the linear system. The coefficient and augmented matrix play key roles in our method of solving linear system. If B1 or B sub 1 equals B sub 2 equals ellipsis equals B sub n is equal to 0 in number 4, the linear system is called the homogeneous system. I already discussed this in our first video. A homogeneous system can be written as ax equals 0, where a is the coefficient matrix. To understand it better, let's have this example. So consider the linear system, negative 2x plus z equals 5, 2x plus 3y minus 4z equals 7, 3x plus 2y plus 2z is equal to 3 are a linear system. Now, these are the given. Now, we will get the constant number. So we have negative 2. There's no y, so 0. Then for z, we have 1. And then we have 2, 3, and negative 4. Then 3, 2, and 2. And so this is our matrices. Then x are x, y, z. So we have 3 x's. And b are 5, 7, and 3. We can write the given linear system in matrix of ax equals b. And the coefficient matrix is A, and the augmented matrix is at the end. So we will just parang combine the 2 with this line here. So we have negative 2, 0, 1, 5, 2, 3, negative 4, 7, 3, 2, 2, and 1. We will understand it better kapag nasa, I think, transformation na tayo. But for the meantime, ito muna siya. Ganyan muna yung representation of ax equals b. Okay? So, yan yan. So, another, the matrix of 2, negative 1, 3, 3, 0, 2, then with the b of 4 and 5 is augmented matrix of the linear system. Ito naman, pwedeng baliktad. Kanina naka-given yung linear system and we get the augmented matrix. Now, from augmented, we will get the matrix. So, we have 2x negative 1y plus 3z equals 4. And for this one, 3x, we don't have y, so plus 2z equals 5. We can express 5 in another form as follows using 2 and 3. So, ito yan, ax equals this one, representation is equal to a sub 11 x sub 1 up to the ellipses up to a sub m1 x sub 1 plus and so on up to a sub 1 n times x sub n, a sub 2n x sub n, ellipses up to a sub mn x sub n. So this representation, parang pinapakita lang nito yung ginawa natin kanina dito sa ating form, no? That this matrix, itong matrix na ito, okay, this matrix, no, ay pwede siyang gawing ganito. And this is also equivalent to this because this one is a matrix and this can be turned into a linear system. At the same time, a linear system can be turned into augmented matrix. Parang, yeah, it's a vice versa of the 3.12 example and 3.13. Okay? Anyway, meron pa pala siya, meron pa siyang continuation. Okay, so the AX is a linear combination of the column of A with coefficient that are the entries of X. It follows the matrix of the linear system A sub X equals B can be expressed as this one. That X sub 1 column of 1 of A plus X sub 2 column sub 2 of A plus ellipses of plus X sub n column of C of A. So consider the matrix here, A sub X equals B, where the coefficient matrix is this one. Then X is X sub 1, X sub 2, X sub 3. So it's equal to B is equal to 4, 1, 0, 2. So parang gawin yan, parang i-distribute mo lang. So for this column, we have X sub 1. So X sub 1, ayan. Then for next column, X sub 2. Then for X sub 3, ayan. So, writing AX equals B as a linear combination of the column of A as in number 6, we have this one. Ito yung number 6, no? So, we have this one. Ayan. Parang, it's just a distributive, parang ganun siya eh. If you still remember yung first na ginawa natin doon sa, I forgot, A column sub 1 of B. Parang gano'n yung kaninang examples natin, di ba? So, yan. It is just like a representation. So, X sub 1, tapos itong column, X sub 2, then this column, X sub 3, then this column. Ayan yun. Okay? Then, of course, we use addition. Then, equals the letter B, that is 4, 1, 0, and 2. AX equals B is consistent if and only if B can be expressed as a linear combination of the column of A and B. So later on, we will try to identify if it is a linear combination or not a linear combination. So that's all about first for a while for the dot product and matrix multiplication. Specifically dot product or inner product, matrix multiplication, matrix vector multiplication, and linear system. With that, thank you very much for your listening.